Okay, in this video, we're going to learn about measures of skewness. So what is measure of skewness? So skewness, it measures the lack of symmetry in a data distribution. The distribution is symmetric if it looks the same to left-hand side here and right-hand side, so the side of the center point. So example here, we have a histogram. So from this histogram, we can say that it has a symmetric or normal distribution. Okay, look at another example here. Okay, let's say a lecturer expects most of the students get good marks. So if it happens, then the curve looks like the normal curve below. So the highest peak here to represent model value. So means that most of students score average marks. Okay, but for some reason, such as lazy student or not understanding the lectures or not attentive, so this curve is not happening. Otherwise, we get another two curve like this. So if you get something like this, we can say that the distribution is positively skewed or skewed to the right. So on right hand side here, we can say that the distribution is negatively skewed or skewed to the left. So data can be skewed, meaning that it tends to have long tail on other side or the other. So for example here, positive skewness, so we can see that long tail on the right. Negative skewness, we can see that long tail fall on the left. Okay, this is example skewness based on histogram. So if based on histogram, if we have something like this, so we can see that this distribution is skewed to the right. We can see that longer tail falls on the right. Okay, in contrast, this graph, this histogram, we can say that the distribution is skewed to the left. So we can see that here, longer tail fall on left hand side. Okay, distribution with fewer observations on the right. Okay, if you look at here, fewer observations on the right. So fewer observation on the right here, meaning that toward higher value. So 10, 20, 30, 40, 50, 60 means that towards higher value from left to right are said to be skewed to the right. Okay, so this is skewed to the right. Fewer observation on the right or towards higher value. Okay, in contrast, distribution with fewer observations on the left. So here, fewer observations on the left or towards lower values. So lower value, 100, 80, 60, 40 means that towards lower value are said to be skewed to the left. Okay, now let's look at another example. Okay, let's say here I take variable height of female students. So we know that average height of female students, for example here I put 150 cm. So this one, center value here will be measures of central tendency, which are mean, median or mode. Okay, so if a distribution is symmetric or normally distributed, value mean, median and mode will be the same. So will be fall on center point here. Okay, let's say height of students or female students are normally distributed. So students who are taller than 150 cm or shorter than 150 cm here will be about the same number of students. So that's what we call as normally distributed or symmetry. However, in real life, it is very impossible to get perfect data. So we might not get a perfect or symmetric distribution like this. So hence, we get another distribution like this. So this is skewed to the left or negatively skewed. So negatively skewed, longer tail will fall on left hand side. So what does it mean by skewed to the left or negatively skewed? Okay, here mean height of female student just now is 150 cm. So if skewed to the left, okay, we can say that there are more taller students as compared to the average height of students. So here, those who are taller than 150 cm are more than the average. Okay, so it means that those who are more than 150 cm is more than 150. Or we also can conclude that otherwise there are less shorter students, means that despite there are less shorter students as compared to the average of 150 cm. Or maybe we can get another distribution which is skewed to the right or positively skewed. So if positively skewed, longer tail will fall on right hand side. Okay, if skewed to the right means that there are more shorter students. So here as compared to the average. So students with shorter than 150 cm are more. Or we also can conclude as there are less taller students, so means that will be despite as compared to the average. Okay, now look at methods on how to determine skewness. So we have two methods here. Either we use graphical method or we use numerical method. So for graphical method, we can use either box plot or we use histogram and we use stem and leaf plot. Okay, for numerical method, we can use measures of central tendency values, which are mean, median, and mode. Okay, another one here we have Pearson coefficient of skewness. Okay, for method using measures of central tendency, okay, for example here, if we do comparison for these three values, if value mean more than median and median more than mode, so we can conclude that the distribution is skewed to the right. So for example here, 60 is more than 52 and 52 also more than 48. So if you do this comparison, if you get like this, mean more than median and median more than mode, so it is skewed to the right. However, if mean less than median and less than mode, for example here, 57 less than 63 and 63 also less than 70, so we can conclude that the distribution is skewed to the left. Okay, another one is we can use by comparing value mean and value mode. So if you have mean minus mode, you get positive value. For example, like this, 60 minus 48, you get positive 12. So we can conclude that the distribution is skewed to the right. Or otherwise, difference mean and mode, we get negative. For example here, 57 minus 70, we get negative 13. So here we get negative. So we can say that it is skewed to the left. Okay. Okay, note that if it is a symmetric or normal distribution, value mean will be equivalent to value median and also will be equivalent to value mode. Okay. If we are using difference between mean and mode, if we get exactly equal to 0, then we can say that the distribution is normally distributed or symmetric. Okay, for method using Pearson coefficient of skewness, also the same, means that if you calculate the coefficient, we get positive, means that it is skewed to the right, or otherwise, if we get value Pearson coefficient of skewness, we get negative, so means that it is skewed to the left. Okay, now let's look at on how to calculate Pearson coefficient of skewness. So there are two formulas on how to calculate Pearson coefficient of skewness. So the first one skewness equal to mean minus mode divided by standard deviation, or we also can use this formula 3 multiplied by mean minus median divided by standard deviation. Okay, now the question is which formula to use. Okay, for example, in that question or in that situation, you have all the three measures of central tendency, means that you have value mean, you have value median, and you have value mode. So you can use either one, okay? So you can use mean and mode, or you also can use mean and median. But if you only have value mean and mode, then you use this formula. Otherwise, if you only have mean and median, then you use second formula here. So how to make conclusion for skewness for a certain data set? So again, either we conclude it's skewed to the right, to the left, or symmetric, or normally distributed. Okay, if this Pearson coefficient of skewness we get positive, so means that it is skewed to the right. Otherwise, if we get negative value, then it is skewed to the left. Okay, if we get the coefficient equal to 0, then we can conclude that the distribution of the data is symmetric or normal. Okay, however, as I said before, in our real life, it is very impossible or very hard to get perfect data. So sometimes we will get the coefficient of skewness, for example, around 0.0128, means that approximate to 0. So normally we conclude the distribution is approximately normally distributed. So that is based on Pearson coefficient of skewness. Okay, now look at if you want to make conclusion based on measures of central tendency. Okay, this is distribution skewed to the left. This is a distribution skewed to the right. This is normally distributed. So again, if skewed to the left, value mean here must be lower than value median, and these two values also must be lower than value mode. So mode is the highest frequency, right? So here, highest peak here to denote value mode. Okay, in contrast, this one skewed to the right, value mean here will be larger than value median, and also must be larger than value mode. So again, the highest peak here represent model value. Okay, however, if you get a perfect curve like this, means that the distribution is symmetric or normal. So where value mean, value median, and value mode will fall on center here, means that value mean, median, and mode will be the same. For another one, you can use value mean and mode. So if you find the difference, if we get positive, means that skewed to the right, and otherwise if we get negative, it is skewed to the left. So that's how we conclude skewness based on measures of central tendency. And another one, we can use Pearson coefficient of skewness. And last one, using graphical method, we can use box plot, stem and leaf plot, and also histogram. Okay, now let's look at example on how to determine skewness. So again, we have data about each of 10 tourists here. Okay, we have the summary measures. For example, here mean is 21.7, median 22.5, model value 23, and the standard deviation is 10.2. Okay, now let's look at the first method using graph. So first graph here, we have box plot. So how to determine skewness? Okay, different people will see a different shape of data distribution. Depends on the graph itself. It is clearly show either skewed to the right or left, then we can conclude or we can get the same conclusion. But somehow, using graph, it is not too clear or too obvious. Either it is skewed to the right or skewed to the left. So that's why we have another method just now, which is using numerical method. So by using numerical method, if we get positive, then we can conclude it is skewed to the right. Otherwise, if we get negative, we can conclude it is skewed to the left. Okay, so if you look at this box plot, so this is a vertically box plot. So here is minimum value and here is maximum value. So we can see here this part, wider area from lower part of Q2 line. Okay, so we can conclude that this data or the distribution of this data is skewed to the left. Okay, okay, now let's move on to histogram. Okay, here why got space here? Because there is no frequency between these two boundaries. Okay, if I'm looking at this graph, first I can see that is it approximately normal? Okay, and if when I see it twice, it is skewed to the left. I can see that more data falls on left. Okay, or more observations on left hand side, or more observations towards lower value. So using histogram like this, it is not too clear or too obvious to conclude it is skewed to the right or skewed to the left, or maybe it is approximately normal. Okay, now let's move on to last graph, stem and leaf plot. Okay, so if like this, using stem and leaf plot, so I can see that it is skewed to the left. Okay, longer tail on the left here. So how to read skewness using stem and leaf plot? So again, if you rotate this stem and leaf plot anti-clockwise here, it will resemble a histogram. Okay, so this part will resemble the bar. Okay, now let's look at numerical method on how to determine the skewness. So here we will use Pearson coefficient of skewness. Okay, let's say here we have all the values, mean, median, mode, and standard deviation. So we can use either one. Okay, either you want to use the first formula using mean and mode, or also we can use second formula using mean and median. So here I'm going to show you using both formula. Okay, let's say for the first formula, skewness equal to mean minus mode divided by standard deviation. Okay, so here mean is 21.7 minus mode 23 and standard deviation is 10.2. So here when you calculate this skewness, we will get negative 0.13. Okay, so we get negative. So negative means it is skewed to the left. Okay, let's say in that situation or in that question, you only have value mean and median, then you use this formula. So 3 multiplied by mean 21.7 minus median 22.5 divided by standard deviation of 10.2. So here we will get negative 0.24. So both we get negative values. So we can conclude that it is skewed to the left or negatively skewed. So what does it mean, skewed to the left or negatively skewed? Okay, again, look at the data here is about age. So we can say that older or there are more younger tourists as compared to the average age. Okay, there are more younger tourists as compared to the average age. So that is meant by skewed to the left. Or we also can conclude it as there are less older tourists as compared to the average age. Okay, so average just now is 21.7. So means that tourists who are younger than 21.7 are more. But we also can say that tourists who are older than 21.7 are less. So that's how we calculate Pearson coefficient and Pearson coefficient of skewness. Okay, if you want to use value mean and mode, for example, 21.7 minus 23, you will get negative value. So if you get negative, you will get negatively skewed distribution. Or otherwise, if mean minus mode, you get positive, then it is a positively skewed distribution.